This is a chat about parsers and combinators, or parser combinator libraries, both of which are things you'll get the definitions of very shortly. Hi, my name is Rob. I do some FP stuff. I do Elixir, I work at Ruby, and at the moment, lots of CSS at a place called CancerAid that I recently joined last week with Andrew Harvey, who you may or may not know. But anyway, cool. So this is going to be a short look at a parsing library, but it's also going to be learning about the concept of what the hell a parser combinator thing is. But first, I'd like to thank Elixir 360 for hosting us. I found this in Melbourne, like I was on the way to Elixir camps, like, wait a minute. Anyway, so NimbleParsec is a library that has been blessed. It is basically Joseph Valim, along with, he put out a Nimble CSV library, like a fast CSV library, and he's recently come up with a parser combinator library named after Parsec, which is a Haskell parser combinator library. There are a bunch of these things hanging around the place in Elixir, but I'm just going to be looking at this one as a bit of a teaching example. But I'm pretty sure this is also a pretty practical one because it's pretty bloody fast, as you might see a little bit later on, at least in terms of the implementation. So, parsers and combinators. I used to do high school debating. I was terrible at it though, so I'm going to eschew the whole, going to define my terms at the opening of the talk and just say parsers are, well, okay, I will go with definition. You can think about a parser as something that starts with, that takes in a string and as a result produces either a stop now, I'm done, or a, okay, please keep going, here's some result I've gotten out of it, and the rest of the string to process. For example, if you've got a string of numbers, you take and you've got something that represents just like parsing or processing the first character, it's a takes in a string and returns a, okay, please going, here's the first number and the rest of the numbers in the string. It's basically a way of stepping through an input and processing it as you go, or rejecting it if it's wrong. So another way, like instead of writing parsers, you might write instead sort of string processor thing, like a value that is representing a string processor. So combinators, on the other hand, there's some formal definition that involves lambda calculus and free variables, and I'm not going to use it here. I'm going to say helper functions. It's close enough. It's basically, this is what the Haskell community's definition of combinators are. Basically, if you know what a pure function is, if you don't worry, if you know what a pure function is, it's basically a helper function that is a pure function. Whatever. Anyway, basically functional style helper, tiny little function things that you tend to combine together to produce a result. So when we've got parser combinator library, we really kind of mean a string processor or a bunch of string processors made up of a whole bunch of little functions that make up a string processor. So, and NimbleParsec is, as I mentioned before, a Performatech thing. And I'm going to chuck this link up at the end so you can visit it if you want to. But for the moment, I'm going to wrangle Keynote because something changed since I upgraded to High Sierra, and now my seamlessly jumping between bits of the presentation thing doesn't work anymore. Anyway, cool. I've got an example project here, and I've just gone and added NimbleParsec as one of the dependencies. So can everyone see what's on the screen so far? Because this is going to be the size and the contrast I've got for the remainder of the talk. Cool. All right. Sounds good. Well, let's move on to our first example. So NimbleParsec is something that you've got the library, and you're gonna import it, and it gives you a bunch of sort of little functions that are sort of little parsers in their own right, and then this thing you've got def-parsec, which is basically say make a parser out of the following things. So I've just got one very little one here, which is just basically parsing an empty string, which is not useful. Let's try that instead. So I forgot to set up my REPL, so let's see how this one works. God, this is probably going to be insufferable, isn't it? All right. Let's make it really tiny and see if we can't keep most of our top half. Oh boy. It's all right. Yep. Cool. All right, there we go. That's close enough. So, hello world. So def-parsec being a macro is going to make us a parse function, which does stuff as you may see in a minute. So I've just called this thing parse for the sake of ease, and I'm going to give it some correct input, ABC. So what we've got as a result, this is just the very, very beginning, but what we've got as a result is unfortunately this like 1, 2, 3, 4, 5, 6 tuple. Unfortunately, I mean, it's been blessed, so this is it's a little bit weird. I didn't expect this massive sort of tuple thing out of the library, but what you do if you wanted to be presenting a nice interface to this is that you basically take the first two things, which are the did it work or not, and here are the results of the parser, and then the rest of them, which includes some stuff like internal state tracking, positional information. I might use this if I was writing a compiler. I don't write compilers very often, so I'm just going to ignore that. So just look at the first two items for the sake of the rest of the tutorial. But what we've got here is string is a function that well, basically, I was going to dig into the guts of how this is implemented, but that's not really going to be super useful. So I'm just going to be going around talking about how you might actually use this. So string with ABC represents a parser that will take in ABC and then stop. So it's only ABC. It's not like a regex where you're picking a bit out of the middle, a long string of an input, for example. This is only the string ABCD. Well, no, there's an end of line, end of file thing that okay, never mind. It's exactly like a regex. Oh my God. See, this is what happens when you ad-lib a live coding talk. Anyway, so in this case, I gave it some bad input, and it's given me an error response back with an error message. In this case, because the only possible say, input that will satisfy it is this thing, it's just saying, okay, I expected this specific string. Can you go and do that, please? This isn't a very useful parser. So let's go and write. I'm just going to put a new line to make it pretty, but let's write, hello world. So we're going to compose this with another parser, with another sort of little helper function here, sorry. And for the sake of it, I'm just going to split up. So when I reload hello world, now I'm going to give it some bad input. It's going to tell me I'm a really bad person. However, basically I expected a string hello followed by world followed by exclamation mark, you idiot. So if you go and satisfy it, you go hello world. Nope, I still expected this, this, and this. All right, fine, okay. Cool, hello world, and now it's gone, I've asked for a string hello followed by a string world followed by a string exclamation mark, and it's come back in the input, the output and said, here's your string hello followed by your string world followed by your string exclamation mark. Now this doesn't seem super useful, but when you start replacing pieces of this and you see what I mean by combining things, combining little parsers together. So hello, sure, all right, let's keep that one as it is. Let's have a couple of different options here. Let's mix it up. So if I go choose between a couple of different alternatives. I don't have mixed formatter on because I don't have really Vim set up properly for this, so I'm sorry if it looks horrible. But if we're going to go Elixir Sid, or is it Sid Elixir or Elixir Sid? I'll lose track.
Elixir Sydney.
Okay, Elixir Sydney. All right, fine, be like that. Okay. What is it whinging about? Undefined function. Oh, choice, sorry. This is a problem when you hop between different Parser Combinator libraries in different languages. You lose track of what calls what. You can splice that out later, the order what.
With a parser and a combinator.
So hello world or hello Elixir Sydney. Yeah, and so it's kind of like doing a regex where you do the hello comma and then parentheses with a Elixir Sydney bar world and sort of separate the options. Yep.
Is the empty string after the array, is that what would be left if there was something after it?
Yeah, I think so. I think that's the remainder. This is where I'm kind of curious to see what this happens. No, okay, no, it's expecting it as a, I think optional input, and this is where I don't know the library well enough to know. I think so. Yeah, I know. Oh, actually, yeah, no, you're right. Sorry, give it too much. Yeah, you're right. So, and the rest shows up in, yeah, okay. Thank you for helping with my talk. Oh, it's a little bit seat of the pants. All right, cool. All right, so that's that's choosing between a couple of different points, and as you might know, you can have your own really complicated with. You can have a big sort of parser in between here, and you end up with these as you combine these things, you can end up with these big, deep, nested branches. And if you were to go and implement a library for a programming language thing, you might have, this is what an if looks like, da 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 da, or this is what a statement might look like, da, da, and you end up with these big trees of possibilities. You're just seeing the very beginning of what these things kind of tend to look like. So again, let's mix it up. I have forgotten the incantation for this, so I'm going to go to my crib notes. If I had a second screen, I would be totally all over this, but I'm just going to copy paste this. Didn't see that, all that. Cool. So for reusing bits, you can just do the top level. It looks weird as hell, and I sort of was like, what is going on? But as I'll get to at the end of the talk, how this is implemented, you kind of need to have things at sort of the top module level, and it at the end produces a module which has a function with a whole bunch of stuff sort of baked in. So looks weird, just trust me. So I'm going to choose between a single word or another helper function we have called, integer, and I'm going to say 5 numbers. So let's see if I broke things. Hasn't yelled at me yet. Okay. So hello Elixir Sydney, which is a word. Hello Elixir, and as you notice, it means we can start getting we can effectively start writing regexy kind of things where we've got some dynamic bit in the middle here, followed by, with the hello dynamic bit and then some other bit. And we'll clean this up in a minute. But or alternatively, we can use that, take advantage of the number choice on this and write. Okay, yeah. So Jean Valjean gets his very own greeting. If there's any musical fans in the audience, I'm sorry, I keep reusing this joke. Sorry, Les Mis. God damn it, people! Didn't you? Is there no musical nerds in the room? All right. Okay, so yeah, so we've got the choice there. If you screw it up, however, then you get something. You get this hideous error message. It's like, okay, I expected byte, and followed by technically correct. Unfortunately, right. So you can start doing things like annotating. So there's a way, for example, to sort of label, like what I was expecting here. What I'm going to describe is a number of 5 numbers, live typo, sorry, or a word. So now it's still horrible, followed by while processing 5 numbers or a word. Congratulations, they're your nice error messages. We're most of the way to Elm. So I'm sorry. Yeah, okay. No, okay. Elm's error messages are lovely, and unfortunately none of the stuff before processing 5 numbers or a word is at all lovely. So it's more a jab at Parser combinator libraries in general tend to have not very nice error messages because it's very difficult to do. Okay, so yeah, we can annotate that, and that's the way of describing at least some of the things here. Cool, I'm going to move on. So something approximating, actually, sorry, who in the room has used regular expressions before? Just hands up if you don't mind. Okay, cool. Yeah, so basically what we've sort of got is effectively something that represents beginning of this, followed by either a, what is it? Okay. So yeah, we mean A to Z plus, because at least 1, or 5 numbers, yeah, so, right, whatever. Sorry, you can mute this bit of the recording. Yeah, very good point. Anyway, so that's kind of what the regex looks like. I had not used regexes for the last 3 years. Haskell, context, sorry, I've been running Haskell for the last few years, and I'm now recently Elixir full-time along with Ruby and some other things. I haven't used a regex for 3 years because there are a lot of just basically people start reaching for this stuff instead. Because it tends to, because you can do the /x thing in some languages where you sort of space it out and you sort of add a bunch of comments and you sort of like basically try and describe what the alphabet, well, the symbol soup in front of you means. But I personally find parsers, once you get used to actually using them, something that is more self-describing.
It's a lot more readable.
I personally think so. This is one, like I'm trying to say my personal opinion. Once I'm used to actually and particularly when you have like larger branches of choices, where you've got like a couple of big sort of choices, I find it starts getting easier to read, as opposed to big spaced out soup of symbols with /x at the very bottom and a bunch of comments.
I guess you could also tailor it to the domain a little more.
Yep.
So you're not just using the building blocks of a regex, you're actually constructing something
Yeah.
that fits your sort of problem.
Yeah, exactly. Yeah, you start much like I pulled out Word earlier. I mean, hell, I forgot to do a couple of things here, but basically, if we can have, for example, pull some of these out into, so middle bit.
You could do something like a credit card or something like that.
Yeah, exactly. Credit card, which represents, and we'll get to that right in the next example. So I'm not going to pull it out. I'm not going to pull them out to separate variables or anything.
Quick question.
Yep.
How does the label thing work? What happens if you didn't match the hello bit? Will it say, well, processing file numbers or word?
Yeah, it's actually. Sorry, I'm not sure I quite understand the question.
Let's say you don't match hello.
Yeah.
Yeah. What will happen?
Oh, sure. At this point, it's a good question. I'm just going to go hell. All right. Unfortunately, it's labeled basically everything before it. So it's this composed with label 5 numbers or 5 numbers or a word. The association is built up in that way. So when you do, sorry.
Can you nest them?
Well, so it's you can you can apply you can stick these together. You can apply these together in any order. Like in the order in which they appear is fine. But if you pull out this chunk and replace it with, if you take out this chunk and replace it with blah, and then you do blah equals the stuff I just pulled out, or you pull out some other middle chunk and compose it that way, the end result doesn't change. I started to say associative, as in associativity is the property of being able to basically pull bits out and then join and have them be the same as if they were just joined back together.
And so if you pulled out the label,
Yep.
So say you put your choice
Yep.
the label,
Yeah.
those out, and you messed up hello,
Mm-hmm.
you still get the label from choice.
Yes, it would, because the total composition matters. And so what you tend to do, if you do actually label little bits of it, each little piece gets its own label. You tend to do it. Unfortunately, because it applies to everything before it, it means you sort of need to checkpoint stuff. I haven't used label in anger, I'll put it that way. Okay, so as I mentioned before, that the output of this was including like the hello and the exclamation. I was like, well, do I really need all that stuff? So what we can do is you can do ignore, which is basically you need to process this, and it will not work unless you do it. However, I don't care if you, I don't actually care about this in the output. So, sorry?
That's optional.
No, optional is different, and I'll just show it very briefly. Hello world. So world is our output. It's basically like we don't care about the hello or the exclamation mark. We just need it to be there. It's like if you're processing XML, you don't care about left angle bracket or right angle bracket. You care about a tag, and so you, for example, you capture the left-hand thing and ignore it, and then you take the middle bit and you transform it into something else that represents a tag, like you give it to a struct or something, whatever, and then you've got the right-hand angle bracket, which you also don't care about. You end up just getting it out of that combination of things, a tag that and without all the extraneous noise. So back to optional. This is, again, because he knows how I'm combining these things, is basically just a combination of a whole bunch of these little things that modify to build up a parser. So hello world with this, where we don't actually care, it can consume it. Otherwise, hello world, and this has just been left on the floor as the remainder, but it's just, it didn't have to provide the exclamation mark. So we go hello world, for example. Now it will complain if we didn't have the next bit. If we took away too much, choice isn't marked as optional. This chunk here isn't marked as optional, so we need to provide it, but the exclamation mark is. So we just go hello world and not end the sentence, and it'll still be happy. So, and it's also ignoring it. So, whatever that means. Cool. All right, I'm really going to move on to the next example. So, something that's a little more preformed. This is slightly closer to what you'd be doing in real life if you were to be using something like this. Whereas this is basically sort of a simple regex, but as you'll see in a minute, you can start getting more fancy. So we've got basically we've pulled out the idea of, like the same way if you want to pull out what a credit card is, you can pull out the idea of a date into a combination of, or a composition of 4 numbers followed by a separator that we don't care about, followed by 2 numbers, followed by, and so when we use this, date parser dot date, then we 1901. So, and then we've got numbers back out that we can then use directly. And so if integer is not going to allow any sort of decimal points or whatever. And you can use integer with a range. So you can say a number of length between 1 character's long and 50 million, or 5, or in this particular case, the domain, we know that years are 4 characters because everyone uses ISO, and neither the Australians nor American date format exists. I am living in my happy place right now. Date parsing recently is part of the work I've been doing. Ooh, man. Okay, so, but the separator thing is, well, actually something we don't care about here, but it's also going to be a pain in the ass to, what if we want to accept, for example, we want to go a dash date versus a slash date. And then we're using the magic of our, the magic of our choice thing to do dash date and slash date. And then we get, so date parser, and it will happily accept this, all this, but not that. It was like, what do you talk? No, stop. No, God. Oh. Look, the important thing is that. Yeah, that's really important. Pay attention to that, and just let's go scrolling.
Can you just put the choice inside the ignore?
Sorry.
Choice string.
Yeah. Well, no. The thing is, if you did the choice, the thing is, if you did choice here, inside ignore.
Ignore choice.
Yep, that's also a way of doing it. So, unfortunately, it's not going to aid my next example, but bingo, sir! Congratulations, you beat the test.
Mix them up, Mark,
This is
You could mix them up.
yeah, you could.
So you could have that last one.
Oh no, actually, sorry, no. You basically, yeah, sorry, my apologies. We don't actually care about it in the output, but if we were to say we actually care about you putting a slash and not a dash, and like not mixing them up, then yeah, that's not going to work. Sorry? Add some state to the parser? You don't want to do that, mate. It exists. There are stateful parsers all over the way, and you can actually write it with this library. Someone was like, please, can you make it stateful so I can write an XML parser? Sorry?
You can use a lookup.
Yeah, if you want even worse error messages. Yeah, look, this is going down a rabbit hole on it. I'm here to do exactly this transformation, and that's date equals, we've got the, which language? Okay, cool, yep. Fun week. We can use the magic of functions to basically parameterize this bit if we want to. And then we'll just remove that duplication. And so we either go date with, you can make this even more fancy if you want to, but I ain't gonna.
That's pretty cool. That's very good. You couldn't use a regex on the side.
You could use a regex if you want. I mean, the reason I haven't used them for 3 years is because the Haskell ones are really hard to compile. So yeah, just ignore that. They don't like the documentation. You don't need documentation. It's just type signatures. That's what Haskell libraries are, right? Anyway, so there are. So basically we've just transformed our parser, and now we've parameterized basically that date thing. So we've got a thing made up of little helper functions to reduce a parser that we can then choose between the parser with this parameter given to it, or parser with the other parameter given to it. And yeah, so I'm going to go straight to a prefab example, which is actually from the README. We've gotten to the point of getting to the README. Congratulations, folks. We're doing great. We've got date is made up of a number and a dash, and et cetera, and then we also got time. We can sort of ignore some bits if we wanted to, make the time zone bit at the end optional. The time zone bit's a massive punt on this one, but that's fine. It's a tiny example. And then we've got the actual like date time sort of parser itself, which is the date and then a T thing in the middle, and then the time. To join two parsers together, to join these compositions together, you need to use the concat function to do it. This is one of the cases where having types makes it, like it will actually tell you need to add this here. Unfortunately, it's not great in that respect. It doesn't tell you enough information to really give you enough feedback. So you start getting a feel for how to use this over time. And
why is this different to the other ones? Why can't you just say time there at the end?
Because,
The other ones use it.
see, I can explain it. Unfortunately, it uses the word bind and monads. I'm going to look in the camera when I say that. But it's like, the problem is, like, I want to describe it with type signatures, and I really haven't thought about how to explain this with. Hey, I throw this to the audience. Anyone want to explain this without using the word join or bind? Anyone?
I'm okay with that.
Okay. Yeah, sorry. It's a little complicated. Basically, if you can make up these things are kind of in this system. These little helper functions make up a parser. But then to join two parsers together, you need to use concat. They sort of are.
If you were
Yes.
to inline time,
Yes. The thing is,
wouldn't need concat anymore.
yeah. Basically, it would go if you were to inline it like so.
No, inline it below.
Oh yeah. If I can inline it below, I was just going to call the entire thing date. Sorry, I just figured this is easier. There's always one. So the only intuition I can really offer is when you have these separate sort of blocks of declaration, to join them together, you need a concat.
Semantic, basically.
All right, and then with my prefab example, ta-da! Congratulations. Or we just wind the entire thing back and. Anyway, so cool. So very briefly, I'm going to go back to Hello World, and I'm going to choose a very, very simple example. And I'm just going to go. Yeah. I mean, Lisa told me, well, it told me because I was referring to it as a variable, not a function that, anyway. So if I do it with,
Simpler explanation. You've got two pipelines, one
Yep.
of which is started with a nil as a first part of the pipeline entry.
well, yeah, it's not a nil, but yeah.
Basically trying to feed the result of the second pipeline back into the front of the first pipeline.
Yeah.
But if you were just using plain Elixir, of course, you've got the tail end of the two pipelines. So it's just an out of order problem.
I don't know enough about what you're referring to
You're
say it.
defining your parsers and pipelines. So you've got
Well,
two
yes,
bounds already.
let's go with, yeah, it is in the the operator that's sort of composing things, but putting parameters in.
It's like if you had two shell pipelines, you wouldn't be able to feed the result of the second pipeline into the first without some magic tool.
I'm probably going to leave that one where it is, if you don't mind.
Pipeline.
I don't quite follow, and I'm seeing you looking at your watch, so I'm going to finish this up.
Sorry,
Good
talking
damn it.
about me looking at my watch.
Yes. Oh, I thought.
Looking at my watch.
Oh, sorry.
Thought going on.
Oh, my apologies. No. I thought I was running over. It's like because I don't have a timer on.
Vibrated on my wrist.
Oh.
So I instantly looked at it, that was all.
God, I'm sorry. I didn't mean to be calling you out. Oh God. It's falling apart. Anyway. Can you tell this was a little more last minute than I prefer? Okay, cool. I'm just going to go to my rescue example to pull out. It is debug. Why is it not showing up?
You're brave, man. Love coding.
Thank you. I appreciate the
Gold
compliment.
star.
So maybe I need to save that. Hello. Okay, so the very capstone for more advanced Elixir users is this thing is not actually composing a bunch of objects which This thing is not actually composing a bunch of objects which are like usually Parser Combinator libraries, you basically got little functions, string to that data structure I showed you, string to it's okay, here's the result, here's the rest of the string. And what you do is you build up all these functions as a big sort of function tree that you then run. This library, in order to be fast, does something a little clever. Instead of building up a chunk of functions, what it's doing is building up chunks of AST, or the Elixir AST. So we're actually constructing a bunch of things, a bunch of code. This is the debug, when you put debug true and it says, all right, cool, here's what I'm going to do. I'm going to spit out everything that we want. This is a little more obvious with the other example, and I may switch over to date parser, which is still sufficiently simple, but you can kind of see what it's doing. It's generating a function here. I'm just going to go all the way to, okay, it's not spitting out. All right, there's a top level function that actually kicks this off. But what we've got is effectively it's doing direct string binary matches in the function headers as part of it, and it's basically got a bunch of functions it's going to jump between, matching different bits of the string as it goes, and it's just basically baking it all down to a bunch of hard-coded functions. And because it's a macro that actually takes all the AST stuff that was actually sort of combined as you're building up this parser and goes poof, and just chucks it in the module for you. So the result being that this is a lot faster than something where it's actually running a bunch of the stuff, where it's actually running these functions and switching between them, as in running the big composition of these anonymous functions being stuck together. In this case, it's faster in Erlang and Elixir to do this version instead, where you bake out a bunch of functions and then you run those instead. So yeah, I mean, metaprogramming for the sake of speed, but also keeping a user interface that's relatively friendly for a Parser Combinator library. I'm going to just briefly do the other example, date parser. Unfortunately, I need to go and change that function. Sorry. Thing is, oh, right, sorry. Cool. Yeah, it's going match on number, dash, number, right, the rest. It's basically this type signature, this function header, is basically doing a really quick match on a big chunk of the string, and then is like leaving the rest which gets shuttled off into the next parser function, which is date one, the rest, and then a bunch of where the hell was all this input kind of calculations, I think. I haven't dug into enough for you to know exactly what is something times one and yada, yada, yada. But basically some state calculation, offset calculation, etc., etc. And here's the other one, date zero, which was the other half of the choice, which is again numbers and then a slash, and then numbers and a slash and whatever. And then a couple of the error messages, or here's the thing that I finished with. It's like, I'm very impressed. I still don't know how half of it works, but hey, go Joseph. He's good at what he does. Cool, but that's basically the end of the talk. So here's the library, Performer Tech, NimbleParsec, and thank you.